This is question 7. Now, what do we know about parallel? Okay, parallel are the same. They have the same slope. So in this case, if we want to be parallel to an x, what's parallel to an x? Another x line, right? And what's the x component of our ordered pair here? 5. So your answer would simply be now x equals 5, and that's it. Okay, so that's all I want on that one, because that one's a parallel. Now, if it would have been perpendicular, then it would be the the y one, right? Then it would be y equals that 3. Okay. Now, who needs the homework packet from last time? Yep, I got that. Let me get these sorted out. I'll be right there to bring you these. That's the one up here. Okay. Back here. Here. And out the top too. Who else needs the homework packet from last night? Anyone else need the homework packet from last time? And here's the handout. We'll use that again today. All right. Okay. Well, we'll go ahead now and get started. We looked last time at 2.5. So we're going to look at questions 7 and 9. We just did question 7. And question 7, we looked at parallel. Okay, and parallel means they have the same slope. An x line has an undefined slope. So the only line that has an undefined slope is another x line. So that one would simply be x equals 5 there. Question 9. We did 10 in class. Okay. I gave you 9 to look at. Now, we want to find our model. And when we read this one, we need to figure out which one's the x and which one is the y part. So a biologist recorded 6 snakes on 16 acres in one area and 15 snakes on 33 acres in another area. Find a linear equation that models the number of snakes in x acres. So what we're looking at here is x is going to represent the acres. So when we write our ordered pairs, they're going to go acres comma snakes. So it's going to be the acres go first, because that's your x component. Okay. Snakes goes second. So I'm going to go ahead and build up the ordered pairs just to get you started here. And when we look at these ordered pairs, what do we have? We have 6 snakes on 16 acres. So my first one is going to be 16. And, and the 6 snakes. So let me write them in the right order. So the first one, we've got 16 acres of land, so that's your x. 6 snakes, that's your y. Then we did another survey on 33 acres of land, so that's your 33 there. And we found 15 snakes. So that's what your ordered pairs should look like, right? Because it said in the question that x represents the acres, then y must be the number of snakes. Huh? Yep, I'll get you that homework packet here in just a second. Yep, you're welcome. Okay, so how would we finish this one out? I'll get you started through one more step. Okay, what do we have? We have what? 2 points, right? So if we have 2 points, we want to find our slope. And what's our formula for the slope? y1 minus y2 over x1 minus x2. And there's x1, y1, x2, and y2. So we'll go ahead and fill this in, and that's going to be 6 minus your 15, right, over 16 minus 33. And what does that come out to give you? Well, 6 minus that 15, that's going to come out to give you a negative 9. And I'll give everyone the homework packet that needs it in just a moment. Down below, we've got 16 minus 33, and that's a minus 17. Negative and negative makes it a positive 9 over 17. Now, what are we going to do from here? I'll do one more step and leave it for you to finish. Okay, what's the next step? You're going to use the point slope formula. And you're going to use that with m equals 9/17. And you'll use that point 16 comma 6 there. And I think you can finish it from there. Because you use point slope, which is y minus y1 equals m times x minus your xy. Okay, and I think you can try to finish it from there. All right. Everything picked up here. So who needs the homework packet again from last time? Yep, okay. All right. You're sure welcome. And hand up goes along. Okay. Anyone else got everything they need? Anyone else need the homework packet from last week? Do you have the homework packet? You're sure welcome. And hand up goes along with it. And we have the homework packet. Oh, probably that from last time. Has everybody got the homework packet now? And the handout from last class period. We've got that? Okay. Well, we'll go ahead now and start the next section. So when we looked at 2.5, I gave you this handout here. Okay, and you can look at the notes online too, and you can watch the video that I put on Canvas on how to use this. But this helps you find the equations of lines. Like for this one, you would use, for this particular question here, okay, that was question 9, you would use the second page because it tells you exactly what to do. Find the equation of a line when you're given 2 points. So what did we do first? We had 2 points, so the first thing we did was we found the slope. That's what we just did here. And then from there you use the point slope formula, which is what you're going to have to do. And then you'll either write your answer in standard or slope-intercept. On question 9, you're going to want it in slope-intercept form here. But you'll use this flow chart to help with that. Well, we'll go ahead now and start the next section. And the next section, I think you'll find it to be a little bit easier. The next section, we're going to be learning how to graph functions that are not lines anymore. So these are going to be curves. So we're going to move on now to 2, 6, and 7. They're combined together because they used to be combined and they got separated out, but I put them back together. So we're going to look at 2, 6, and 7. We're going to be using the back cover of our textbook. And so we're going to be using the back cover of our textbook for these common graphs. Okay, so the back cover of the textbook has these common graphs. And if you don't have your textbook with you, that's okay, because I'll put them up on the screen. But these are the ones we're going to be using. We're not going to use the reciprocal function, because that's at a later chapter. But these are the common graphs that we're going to be using. What we do is we identify what function it is, then we figure out what the graph should look like, and then we talk about any translations that might be involved. So we'll start with some easier ones. So let's try to graph this. Let's try to graph f of x equals, how about 3 x cubed? Now, what we look at is we look at the fact that this is not a line. Okay, this is a cube. It's got an x cubed on it. So when I go to the back cover of my textbook and I look it up, the graph should eventually look like this. Okay, that's my cube graph. So it's not a straight line anymore. It's going to resemble this. So that's what it should look like. So what I usually do is I look it back up in the back cover, and then I do a quick sketch on the side of what it looks like. So the cube graph, a quick sketch looks like this. This is x cubed here. Now, what about that 3 in front? Okay, that 3 in front is going to be like the slope. It's not the slope because these are nonlinear, but this is like the slope. So that's going to be 3 over 1. And just like the slope, we would go up 3, and we would go over 1. Now, our graph needs to look sort of like this. Is there any number on the end here? No. Okay, there's no other numbers. That 3 is like your slope. There's nothing on the end, so we're going to start at 0, 0. Okay, we'll talk about one that has a number on the end in a moment. Okay, so this was cubed. So the cube makes my graph look like this. Let's go ahead now and plot some points. It's going to start at 0, 0. So I'm going to start right here at 0, 0. And it needs to look like this. Okay, so we're going to start at 0, 0. And what's that number in front? Okay, that's a 3 over 1. So that's going to be up 3 and over 1 unit. So that's another point right there. And that's at, when I move it up, 3 over 1, that's going to be at 1, 3. Now, we don't connect them together with a straight line because this is curved here. So we're going to go ahead and curve it like this. Now, how do I get the other half? Because this is only this half. How do I get the other half? Well, it needs to go down. So I start back at my 0, 0. Okay, and I'm going to go down 3 units and back 1 unit to make another point. And that would be at minus 1, minus 3. Okay, and then I can connect them together. And then there's my graph. And we're going to do several of these. This is a cube graph. Okay, the number in front represents the slope in a way. It's not technically the slope, but it behaves like the slope. Okay, let's try another one here. We'll try another one. This one's going to be a different function. That was a cube. Let's look now at a square root. Let's try a square root here. So let's try and graph this one. Let's try and graph, and it can be f of x or it can be y. But let's try to graph y equals, how about 2 square root of x plus 5. Now the first thing we're going to do is we want to figure out what that graph should look like. And so we go to the back cover of our textbook. We look at our common graphs, and we figure out what operation is happening to that x. So what are we doing with that x? Okay, we're taking the square root, right? So the graph needs to look like this. And see how there's nothing over here, it's just here. So this is a square root function, so the graph is going to look similar to this. This is our pattern. Okay, so it's going to look like this. Now, what's happening with ours? On ours, we've got this 5 on the end here. The number on the end tells me how far to go up, because that is your y-intercept. Remember when we graphed lines, the number on the end told you where to start. Same thing here. This has a 5, so that means I'm going to go up 5 units. And so where am I going to start at? Well, I'm going to start at 0, 5, because that is your y-intercept there. Okay? Now, the graph needs to look like this. So let's go ahead and plot our point. And it's going to be at 0, 5, so that's at 0, and up 1, 2, 3, 4, 5 units. Okay? Now, what number's in front of the square root? 2. So that is going to look like this, 2 over 1. So that's going to be up 2 and over 1. So we're going to start here, my y-intercept. We're going to go up 2 units and over 1 unit. So that's going to be right there. So we went up 2 and over 1. So that's going to be at the point 1, 7. Now I connect them together. It needs to resemble this picture. See how it looks like this picture? Do I have to worry about back here at all? No. Why not? Because it needs to look like that. When I connected them together, connect them in such a way that it looks like that. It needs to look like that picture. It doesn't go back here at all, because that's our goal. It needs to look in a way like that. Let's do another one. Let's look at a square. Okay, so what is the graph going to look like? Well, we go to the back cover of our textbook. And what operation is happening to that x? It's being squared, right? So we go to the back cover of our textbook, and what should the graph look like? That. Because why is it going to look like that? Because it is what? It is x squared there. So it's going to make a u. Where are we going to start at? This minus 1, it's negative. So what does that make the graph do? Makes it go down. And what should it look like? Okay, it needs to look like this. X squared needs to look in a way like that. Now, it might be upside down. And in this case, it will be because this is negative. So where are we going to start at? We're going to start at 0, negative 1. Oh, thank you, Ron. Yep, you're welcome. Okay, so that's where we're going to start at here. What about that negative 4? That is like your slope. So we're going to make that a negative 4 over 1. So we're going to have to go down 4 and over 1 unit. So we're going to start at 0, negative 1, which is here. And what are we going to do from here? We're going to go down 4, so 1, 2, 3, 4, and over 1. So that makes my new point 1, if we take 4 away, minus 4. I'm going to connect them together. That's half of it, right? Now, what should the other side look like? It needs to look like this. Make a U. Why is ours upside down? It's upside down because the number in front was negative, so that flips it over. We went down 1 unit here, okay, so that's where we started. How do we get the other side? Well, we go down 4, right, over 1. And you don't have to label the ordered pairs. You can, but you don't necessarily need to. And that would be at minus 1, minus 5. And if I connect them together, there's my finished graph. Okay, so we went down 1 unit at the beginning. We started down 1. Why is it upside down? It's upside down because the slope, or the number in front, is negative. It's not really your slope, but it works the same way. Let's try another one. Let's try an absolute value. We want to go ahead and graph this one. Well, if we want to graph this one, and we go to the back cover of our textbook, what operation is involved? Absolute value. So if we go to the back cover of our textbook, it's an absolute value. So what should it look like? It should look like a V. So what we always do is we look at the operation, we identify what the graph should look like in a way. So it's going to look like a V. So it's going to look like that in a way. Now it might be upside down. Okay? It might be moved over, moved up, moved down. What about this one? Is there a number on the end? Back here? No. So where are we going to start at? In this case, we're going to start at 0, 0. So that's where we're going to begin with our V. Now, what about the 1/2? We need to make sure it's over 1. These have to be over 1 to make it look right. Otherwise, it'll be too stretched out. So we've got that 1/2. So I'm going to write that as 1/2 over 1. Must be over 1. And we're still going to go up 1/2 over 1. Has to be over 1. So if it's a fraction, you make it over 1. Now, where do we start at? Start again at 0, 0. So there's that. We're going to go up about 1/2 over about 1. So up about 1/2 over about 1. So that's going to be at 1, 1/2. We're not going to connect them together with the curve. It should make a V. All right, so we need to make sure we have a V there. So we have 1/2 of it. If I connect these together, I get that. Now, that is only 1/2 of it. Okay, we have that 1/2 of the graph. It needs to look like a V. So how do I get the other side? I go back to where I started from, and I'm going to go up 1/2, back 1. And I'm going to put my other point right here. Minus 1, 1/2. And that is now going to give me my other point. My graph looks like that. Okay, it makes a V. Why does it make a V? It makes a V because it is an absolute value. Okay, let's do another one. And then we'll add more. Let's try to graph f of x equals, how about minus 1/4 times the cube root of x plus 2. Okay, so what are we going to look at? We're going to look at the operation involved first, and what operation is involved with that that x. It's a cube root, right? We're looking at the cube root of x. And what does that look like from the back cover of our textbook? If we go back and we look, it's a cube root graph. And so the cube root graph looks like that, doesn't it? That's our cube root. So we need to make sure that it looks like that. And so the cube root graph looks like this, in a way. So that's our basic graph. So the first thing we always do with these is we look at it and we figure out what operation it is. Then we look up the graph that goes along with it. And then we deal with our translations. That 2 is positive, so that's going to move it up 2 units. So where are we going to start at now? We're going to start at 0, positive 2. We've got a minus 1/4, so that has to be written over 1. So that's going to be minus 1/4 over 1. So we're going to go down about 1/4 and over 1 unit. So the first thing we do is we plot our point. We plot that 0, 2. So that's right here. 1, 2. And then what are we going to do from there? Okay, it needs to look like this. We're going to have to go down about 1/4 over about 1. And you don't necessarily have to label them if you don't want to, but we went down 1/4, okay, over 1. So down 1/4 over 1, we connect it together, and we get that half. Now, how do we get the other side? Needs to look like this. Ours is upside down. Why is ours going this way? Because it's negative. Okay, so we need to make sure if this side's going down, then this side has to go up, so it finishes it out. We go back to our original starting point right here, and we're going to go up, go the opposite, back 1, and that's going to be approximately there. And we can connect them together, and there is your graph. A lot of times I label the points, but if they're really close together, you don't have to. It just makes it easier. But if you don't want to label them, you don't need to. Just make sure you start at that 0, 2. You're going to go down 1/4 over 1. That makes that spot, that point there. Curve it. Go up 1/4 over 1. That makes that side. So now let's review everything we've talked about so far. So the first thing we're going to talk about is numbers on the end. If the number's on the end and it's positive, that moves the graph up. If it's negative, that moves the graph down, right? So like this one. That 2 on the end, that was what? Positive. So what did it do to the graph? Moved it up, okay? So numbers that are on the end, if they're positive, they go up. Negative, they go down. Number in front of the x. Okay, if it's in front of the x, that is similar to your slope. Okay, so that's going to be like the slope, and it must be over 1. Okay, so it has to be over 1. So the numbers in front of the x, okay, of the variable, that's going to behave like your slope. Now, what we haven't talked about yet is how we can move it left or right. And numbers, this is new here, numbers inside the operation. And that means in the parentheses, under the roots, etc. Positive values move it back to the left. Negative values move it to the right. They're the opposite of what you think it would do. So when we go to graph things, we look at our translations. These are called translations. The number on the end, that controls how far up or down it goes. The number inside the operation is your left and right. And the number in front of the variable, well, that acts like your slope in a way. And once you do several of these, they're not difficult. It's non-calculational. It's just looking up the correct picture and filling it in. So let's do another one of these. No, it's opposite of what you think because you're going to be setting them to 0. So the opposite of what you think they would do. It's backwards. So positive numbers move it to the left. Negative numbers move it to the right. Okay, that's something that you got to remember because you're basically setting it to 0. And it'll make sense when you look at one of these. I know, it's opposite of what you think it would do. So let's try and graph this one. So first thing I look at is what should it look like? It's a square. And so if I go to the back cover of our textbook, the x squares look like a what? It looks like a U, doesn't it? So the first thing I do is I identify the graph that it goes with. Go to the back cover again. It's a square, so it looks like that. Now, is there a number outside of the parentheses? No. Where is that 5 located at? Okay, that 5 is located inside the operation. And that 5 is negative inside, so it's opposite of what you think you're going to be doing. So you're going to be moving that where? You're going to be moving that to the right 5 units. It's the opposite of what you think it should be doing. Okay, so we'll move that forward 5 units. Is there a number on the end? No. So where are we now going to start at? We're going to start at negative 5 because we're moving it forward, or positive 5 because we're moving it forward 5 units. We're not going up or down any, so we're going to be at 0. So we're going to be forward 5 units at 0. So let's look at that. It's the opposite of what you think it would do. So it's going to move it forward instead of backwards. So we're going to be over 5 units. So 1, 2, 3, 4, 5 units. We're not going up or down any, so we're going to start at 5, 0. Now, there's no number in front, so what number do you think will be there? 1. And so that's going to be, again, a 1 over 1. So up 1 and over 1. So we're going to go up 1 and over 1. And you can label these if you want to. So that would be at 6, 1 there. And we're going to kind of curve it. What about the other side? It needs to look like that, doesn't it? So how do we get the other side? We go back to our starting point, and we're going to go up 1 and back 1. And that would be at 4, 1. And we curve it like that. So there's our graph. And so what did we do to the graph? All we did was we shifted that graph what? Forward 5 units. Because what you're basically doing is setting this to 0. And if you set this to 0 and solved it, you would get 5. So that's why you move it forward and not backwards. Let's do another one. Okay, so we need to graph this one. Now, what operations involved with this? Cube. So, we go to the back cover of our textbook, and we look up that x cubed graph, and our x cubed graph resembles that, doesn't it? Is everyone okay with that? So that's the first thing we do, is we go to the back cover of our textbook, we find the correct graph. Okay, so we find that correct graph, write it over the side, so that's what it's going to look like, in a way. Now we start with our translations. The 3 is on the end, so that is positive, so that 3 on the end is going to make it move up 3. The 5 is inside the operation here, and it's positive, so that's going to force it back 5. And then what about the 2? 2 over 1. Up 2 and over 1. So let's identify where we're going to start at first. So we've got our translations labeled. Let's see where we're going to start at. We're going to start, what? Back 5 units. So that's going to be at a -5, and we're going to start up 3. So we're going to start at -5, positive 3. Okay, so -5, positive 3 is where we're going to begin. Let's go ahead and find that point. So back 5 units, up 3 units. Okay, so there's my starting point. Now, what are we going to do from here? We're going to have to go what? Up 2 over 1. So let's do that. We're right here. Okay, that's where we're at. We're going to have to go up 2 over 1. So up 2, back 1. If we go up 2, back 1, that's going to be at -4. And up 2 units makes it 5. We're going to curve that. And so it looks like that. Now, we're not done yet, because what does the graph need to look like? It needs to look like this. Ours is close to that, but what do we need to do? We need to get the other side, so we're going to go back to our starting point, and we're going to go down 2, back 1. If we go down 2 and we go back 1, that's going to be at -6. And then we're going to go down 2, so that's going to be at -6, comma 1. And then we can connect them together. And there is my picture. And so what happened to the graph? Let's talk about that. What happened to this graph? This graph got moved up 3, and it went back to the left 5 units because it was positive, opposite of what you think it should do. So you would think it's positive, it moves it to the right. No, it's negative. Or sorry, positive, so you move it back to left to the negative part. So left and right is opposite of what you think it should do. Let's do another one. So this is a square root graph. We look it up, and it looks like that. So the first thing I did was I went to the back cover of our textbook and I looked up that graph. If you don't have your textbook, that's fine because I just drew the picture, but that's what we want. So we want it to look like that. Now, ours may be upside down, but it's going to be moved over and up and down. And then I start looking at my translations. So the positive 4, what is that going to do? That is located where? On the end, so that's going to move it up 4. And this negative 2, what happens with it? It's negative 2, opposite of what you think it's going to do, so it's going to move it forward to the right. And what's out in front of it all? Minus 6 over 1. So down 6 and over 1. Where are we going to start at? Okay, change your sign, so that makes it a positive 2, comma, 4. So we're going to start at 2, 4. Okay, so that's where we're going to start at. So let's go ahead and plot that point. So over 2, up 4. So right there it is at 2, 4. And what are we going to do from this 2, 4? At 2, 4, we're going to have to go down 6 units. So there's 1, 2, 3, 4, 5, 6, way down here, over 1. So that's going to make my second dot. We went down 6, right? Over 1. And that makes my second dot way down here, and it's going to be at 3, because we went over 1, minus 2. When we connect them together, it looks like that. And is that what our graph should look like? Yes. Why? Because what's our original supposed to look like? That. Does it look similar to that? Yes. Why is it upside down? It's upside down because this is negative. Okay, why is it so large? Why has it been stretched vertically that much? It's been stretched by that factor of 6 because of the 6 in front. So it makes it 6 times as big. It's also been moved up 4, right? Up 4 over 2. Now I'm going to give you a graph, and I'm going to have you figure out what you think the equation is. So I'm going to give you a graph now, and you're going to have to figure out the equation that it came from. So now we're going to do the opposite. I have given you a graph, and you're going to find the equation. So the first thing we look at is we look at that graph, and we look at the shape of the graph. Now the graph is shaped like a V. And which one looks like a V? Okay, absolute value looks like that V. So it looks like that. So our graph looks like that. So what operation is involved with it? Absolute value. Okay, so we know that. So we know, to start with, it's going to have an absolute value. Okay, now we need to figure out the pieces. So what happened here? Well, there's a 3, okay? So that 3 is on the end, so that's going to be a plus 3 because we moved the graph up what? Up 3 units. That goes on the end. Now, what did we do here? We moved it to the right, back to the left, 4 units. So that means we would have to have a positive 4 there. And don't worry about the number in front because it's just 1 over 1. Okay, these are all going to be just 1 over 1. I don't give you anything more complicated, but that's going to be your answer. Let's double check and make sure. Positive 3, moved it up. Positive 4 moves it back. That matches with this graph, doesn't it? Right? It's an absolute value. Why is it an absolute value? Because it makes a V. Let's do one more of these, and then we'll talk about another function. So again, I'm going to give you a graph. So I'm going to give you a graph, and you're going to have to figure out what it came from. So there's my graph. Okay, I want you to find the equation. Well, what does it look like? Can someone tell me what graph you think it is? What function? Does anyone know? You can look at the back cover of your textbook, or you can look back in the notes. We've done this one quite a bit. What do you think it's going to be? Not square root, right? Because square root would be this. We'd only have half of it, right? Which one do you think it is? It's going to be a cube, right? Looks like that, doesn't it? So refer to the back cover. It looks like that. So we know that it's going to be a cube. Are we moving this graph left to right any? Because this is going to start here at 0, 6. Are we moving this graph left to right? No. What is the only thing that we did? All we did was we moved up 6 units, didn't we? So if we move up 6 units, what's going to go on the end here? Plus 6. So what would my answer be for the equation? And we don't put numbers in front because I don't give you any that are complicated to make you count. There's a 1 because it's basically up 1 over 1. It's an x cubed because it looks like that. It's going up, so it's the correct shape. We're not moving left to right any, so it's just an x cubed. We did move it up what? 6, see? And that's your graph, or that's your equation there. Now let's look at another function. The next function that we're going to look at is the greatest integer. These are called greatest integer bars. So if you see those are called greatest integer bars. Not absolute values, greatest integer. And the graph of the greatest integer looks like a case of stairs. Now we don't do much with the greatest integer other than we graph it. Okay, but there's your greatest integer. Looks like that. Looks like a case of stairs. Notice it starts with a closed circle. So that's very, very important. You always start with a closed circle. So whenever you start graphing these, you always want to start with a closed circle. Now they're going to resemble a case of stairs. It's no more difficult than any of the others. So this is a greatest integer graph. So all the translations behave the exact same way as we did before. It is a little bit different. And so the graph of that is a greatest integer function, and it looks like a case of stairs. Okay, so it looks like a case of stairs. Where are we going to start at? Where's that 5 located at? 5 is located on the end again, isn't it? So if it's on the end and it is positive, what does it do? Moves it up. Do we have a number inside of my bars here? No. So nothing moves left or right. So where are we going to start at now? We're going to start at what? Yep, at 0, 5. And when we begin graphing these, the greatest integer graphs, they have to have a closed circle. So wherever you begin, it gets a closed circle. So we're going to be at 0, 5. And it starts with a closed circle. Now, what's in front? 2. So that is going to be 2 over 1. So we're going to have to go up 2 and then what? Over 1. Up 2 over 1. And we make another closed circle. So up 2 over 1. And if you want to, you can label that. That would be at 1. Up 2 would be 7. So 1, 7. And you'll do another one. Okay, up 2 more. Over another one. So that would be at 2, 9. And it looks like this. Now we need to get a couple of them in the opposite direction. So we're going to go down 2, back 1. Open circle. Because, well, let me draw it right here. Okay, so let me down 2, back 1, right there, and that's going to be an open circle. And then we go down 2, back 1. It's going to be right here with an open circle. And so you just make your graph look like that. It should look like a case of stairs. All of my closed circles are here. The open circles are behind it. The part I'm really concerned about is make sure you start at 0, 5. That's the most important part, that you started up 5 units. Okay, and make sure it starts with a closed circle. And you go up 2 over 1, up 2 over 1, make your closed circles. Let's do another one of these. I saved these for last because I think they're the trickiest ones. Let's try and graph minus 3 times the greatest integer of x plus 4. Okay, so first off, graph looks like a case of stairs. So a rough picture of it would be this. Greatest integer, case of stairs. Okay, now, where is that 4 located at? Inside the operation. If it is inside the operation, that moves it left and right. It is positive, so the opposite of what you think it should do, that's going to make it what? Move back 4 units. Right? Opposite of what you think. That's the way I remember, is it's opposite of what you think it should do. Where now are we going to start at? We're going to start back 4 units. So that's going to be at a -4. Are we moving it up or down any? No. So we're going to start now at -40. There's no number on the end. So we're going to start at -40. So let's find that point, -40. Which is right here. Make sure you use a closed circle. What's in front of it? -3. So we need to write that then as a -3 over what? 1. So that should move down 3 units over 1. So down 1, 2, 3. Okay, move down 3, right? Over 1. And that's going to make my new dot right here. And that should be now at -3, -3. We'll do another one. So you'll go down 3 more. Back another one. So that's going to be right over here. Okay. And that's going to be at about, that was at -3, -2, down 6. And then we just connect them together to make our lines. Okay, and we'll do another one. Down about 3. And over. And we'll do one in this direction as well. So we're going to go up 3. Over 1, about over here. And these do not have to be perfect graphs. Okay? This is a quick sketch. So let's talk about what happened to the graph. We moved the graph, what? 4 units to the left, didn't we? Right? Because it was positive. So we moved it back 4 units. What else did we do? Instead of going up from left to right, what is this one doing? This one's going down from left to right. What else did we do? Instead of it being at 1 unit tall, now it's at 3 units tall. And it's going down instead of going up. Because that represents like your slope. It's not your slope, but it's close enough. We've got one more part to look at in this section. And we're now going to talk about piecewise defined functions. So we're going to look now at piecewise defined functions. And these are going to be done in pieces. So they're going to be done in different pieces or different parts. Let me make sure I get the inequalities right here. We're going to first learn how to evaluate them. We're going to find the requested value. So we're going to find the requested values. I'm going to give you this function. And how about x squared, and let's say if, okay, x is, how about less than or equal to 5. How about we have x is going to be between 5 and 9. And how about if x is greater than or equal to 9? Okay, so this is a piecewise defined function. I want you to find the requested values. So I'm going to give you now numbers to plug in. So I want you to find all of these. We'll probably do 6 of them off of this picture, off of this graph, so we can, or this function, so we can see how it works. So I want you to find each of these. Now, this is your value of x. So the number inside is your x value. Let's talk about what each of these mean. Okay, so this one says this is for values of x that are less than or equal to 5. Okay, so they're going to be less than or equal to 5 for that first one. That's our first row. This row is for numbers between 5 and 9. And the last row is going to be for ones that have numbers 9 or above. So greater than or equal to 9. And we're going to label these 1, 2, and 3. So this will be 1, just so we can keep track of things. This will be 2, and this one will be 3. Okay, so this is a piecewise defined function. It's done in pieces. So the first row, okay, if your number is 5 or less, it goes in this row. If your number is between 5 and 9, it goes here. This is your function that you use. If it is larger than or equal to 9, it goes here. So I'm going to have you plug these values in and see which one it goes into, and then find the correct value. So let's look at 4. Okay, which row would 4 fall under? Okay, look at my values. This is for ones that are less than what? 5. Between 5 and 9, bigger than 9. Where's 4 at? Is 4 less than 5? Yes. So it's going to fall under row number 1. Now, if I look at row number 1, what's in row number 1? 4x. So I plug my value in, so that would be 4 times 4, which is then 16. You only plug it into one of the rows. Only goes into one of them. What about 8? What if I plugged in 8? Which row would this one fall under? 2, right? Because 8's in between 5 and what? 5 and 9. So that would fall under row number 2. And what do we get out in that row? -3, right? So that one's going to come out to be what now? Sorry about that. That one comes out to be, doesn't matter what it is, it's a constant, -3. Because it falls under row 2. What about 10? Which one would it fall under? Third row, row 3. And what do we do with it? It's x squared, so what are we going to do? Take the 10 and we square it, and that gives you out now what? 100. What about the next one? -3. Where's -3 at? Which row? Okay, yep, first row. So what are we going to do with it? It's going to be 4, right? Times my value, which is a -3. And what does that come out to give you? -12. So there's that piece. What about 5? Which row would it be under? Now be careful with this one. Is it under first row or the second row? Okay, it's going to fall under what? The first row. Why the first row? Because it can equal. Be very, very careful with that. It can equal that 5, so it has to be under the first row. And what would that now be? That first row is going to be 4x, so that's 4 times a -5, which is then what? -20. What about f of 11? Which row would this one fall under? Okay, it's definitely going to fall under row 3. Why row 3? Because it's greater than what? 9. So that's row 3. And what would that be? 11 squared, which is then what? 121. Did I make a mistake? Oh, did I make? Oh, my mistake. Positive. Sorry about that. I just copied down the wrong sign. I wasn't thinking. Sorry about that. Should be positive 5 there. I'm now going to do one of your homework questions for you, just to make sure we understand the directions. There's only 2 of these in your homework. Let's look at homework. We're going to look at 2, 6, and 7. Let's look at 12. Okay, just to make sure we know how these work, I'm going to work out question 12 for you. You can do 13. So here's my piecewise defined function here. What value are we trying to find? We want to find f of 6. So that means my x is going to be what? 6. Now, let's see what we've got. Row 1 is going to be for what? Numbers that are less than or equal to 0. Row 2 is for numbers that are between 0 and what? 5. And row 3, the last one, is for numbers that are larger than what? Larger than or equal to 5. So which row is this one going to fall under? Okay, 1, 2, or 3? It looks like it's going to fall under row what? 3. And what is that? Okay, row 3 was f of x equals x. So what's that going to come out to be? It's simply going to come out to be what? 6, because that's all you have to do. Did I plug it into all of them? No. Which one did I plug it into? Row 3. Only goes into one of them. What about 13? We'll just talk about 13. Which row do you think 13 would go in on this negative 6? Okay, we've got to watch which way it goes. Okay, negative 6 now. This is for numbers that are less than 6, 6 and 8, between there, greater than 8. If I look at negative 6, it's going to fall under what? The first row, isn't it? Right? Because negative 6 is less than what? 6. So it's going to be here. Now, when I plug it in, what would I plug in? It's going to be 8 times a negative 6, because that's my number, plus what? Plus 1. So it goes into this one. Not all of them. It just goes into the first row because it is for values of x that are what? That are less than 6. And negative 6 is clearly less than 6. So all you would do is plug your negative 6 in here. Right? And if I plugged it in there, that would be a minus 48 plus 1, which would then be a minus 47. Now let's learn how to graph these quickly. So we're going to learn how to graph these quickly. And what we do when we graph them is we just plot points. Okay, now we got to watch the signs here. We're going to have to plug numbers in each row. And we also need to make sure we know what gets an open circle and what gets a closed circle. So greater than or equal to, less than or equal to, those get a closed circle. Strictly less than, strictly greater than, those get the open circle. And so the first one, we're going to use a closed circle. The other one gets a open circle. Now what we do is we pick two numbers in each row. And this is going to be row 1. And this one's row number 2. Okay, so first thing we always do is we always plug our value in. Okay, so we plug it in. Okay, so row 1, we're going to use x equals, plug in that 2. Now, what is row 1 going to be? Row 1 is the constant function 6. So it doesn't matter what we put into the first row, what do we get out every time? It's a constant function, right? So we get out 6. So if I plug in 2 for the x value, what do we get out? 6. And that's going to be the ordered pair 2, 6. Now we need another number in that row. And what is this saying here? Watch the way the inequality goes. You have to be very, very careful with the way the inequality goes. It's opening towards the x, right? This is for numbers that are what? Greater than 2. Look at the way it goes. Greater than or equal to 2. So let's pick another number in there. How about 3? Okay, 3 is bigger than 2. If I plug in 3, what do I get out for row number 1? 6. So that's going to be my second point, which is 3, 6. And we're going to graph that. So this is going to be row 1, and I'm going to do this one in blue. So let's see where we start. Okay, we're going to start at 2, 6. Okay, 2, 6. There's that point. It has to get a closed circle, doesn't it? Okay, so closed circle at 2, 6. Now, what's my next point? 3, 6. So that's over 3 and up 6. Connect them together. And that's that. That's a constant function at 6, right? So it's a constant function at 6. Now we look at row 2. For row 2, we plug in the same value of 2. So for row 2, we're going to plug in, again, the same number. We're going to plug in that 2. And if I plug the 2 in, what do I get? If I plug in 2 for x, I get 4 plus 2, which is then what? 6. So that is now the new ordered pair, 2, 6, which is the same as the other one. What about another value? Okay, this says we want numbers for this row that are what? Less than 2. And you can pick any number that you want. I'm just going to pick 1. 1 is less than 2. If I plug in 1, I get 4 plus 1, which is then what? 5. So that's now the next ordered pair, 1, 5. Plot them. So this one's going to have an open circle here. It's the same 2, 6. What's my next point? 1, 5. So 1, 5 is right here. It's going to go together and make a line like that. Okay, because it's going down. So see how they're done in pieces, in sections. This section from here on is a constant. This part for row 2 is what? Going down. Right? Let's do one more. The next one's going to have 3. They're done the exact same way. I only gave you 2 of these in your homework. So there's only 2 of them. There's one like this. and there's one that has 3 parts. And I'm just making up one here to kind of resemble what you've got on the homework. This will be if x is now greater than or equal to 1. So this is what we're going to look at here. I'm going to have you graph this. And the first thing we need to figure out is what gets what. Okay, so greater than or equal to, less than or equal to, they are going to get a closed circle. Strictly less than, strictly greater than, they get an open circle. So this one gets a closed circle, open circle, right? And this one gets a closed circle. I'm going to go ahead and pass out the sign-in sheet here. I had it somewhere. So we'll go ahead and pass out the sign-in sheet. This is going to be the last question that we look at. And we'll have to do 2-8 on Tuesday. So Tuesday we'll have to finish up 2-8. So we'll turn in that homework on Thursday then. Okay, so let's try to graph this one. And this is row 1, row 2, and row 3. Again, be very careful with the inequalities and which way they point. So this one, row 1, is going to be for what? Numbers that are what? Less than or equal to a -1, because it's going that way. This one, row 2, is between. See, they switched around. This one's in between -1 and what? +1. And what about this one? Okay, this one is for values of x that are what? Bigger than 1. So let's do each row, and we pick numbers in each row. So the first row, you always plug your value in. That's what you always do, is plug it in. So row 1, we're going to plug in x equals a -1. Okay, and what's my function on the first row? It's x squared. So -1 squared, what does it become? +1. As an ordered pair, because this is your y here, don't forget that's your y. As an ordered pair, this would be -1, +1. We need another point in that first row. What is it for? It is for values of x that are what? Less than -1. So how about -2? It's clearly in there. These are row 1 here. If I plug in a -2, when I square -2, what does it become? +4. So that is now -2, +4. Let's go ahead and plot that out. Okay, so -1, +1, that's here. And we're going to use a closed circle. Let me label it. Okay, that's going to be at -1, +1. What's my next point? -2, okay, +4. So that's clear up here. Connect them together with a curve. Why is it going to be a curve? Because it's square. Remember we talked about the square? So that's going to be curved like that. Okay. What about row 2? Well, in row 2, we check our endpoints. So we're going to plug in x equals -1. In row 2, if I plug in a -1, what number do I always get out? 5. So if I plug in -1, I get out 5. So that's minus 1, 5 there. If I plug in x equals 1 into row 2, what do I get out? 5. So what's that going to be? 1, 5. Now these get open circles. So we've got minus 1, positive 5. So here's 1, 2, 3, 4, 5. And it gets an open circle. The next one is going to be at 1, 5. And it's over here. And it also gets an open circle. And when we connect them together, that makes a straight line there. Okay, because why do they get open circles? Because strictly less than, strictly greater than. And what about the last one? Let's look at row 3. All right, so row number 3, we're going to plug in x equals 1 again. Okay, we're almost finished. So let's try to finish this up quickly here. Okay, row 3. If I plug in 1 into row 3, what do I get out? Well, that's going to be 1 minus 1, which is then 0. So that's that point, 1, 0. So over 1, up 0. So that's right there. And it's going to get a closed circle. We're almost finished. And what about the next point? We need a number bigger than 1. How about we choose 2? If I plug in 2, then that's going to be 2 minus 1, which is then 1. And that would be the point 2, 1, which is over 2, up 1. Right about there. Connect them together, and that makes your graph. So it looks similar to that. We'll cover some more of these if we need to next time. What's our homework going to be, though? Just so we know, we didn't get to 2/8 like I wanted to. 2/8's a quick section. So your homework is going to be 2/6 and 2/7. You can turn that packet in on Tuesday or on Thursday. So you turn that in on Thursday. And if you've got homework from last time, you can turn that in. I also have graded homework to hand back as well. Let me find the stack here. Okay. Yep, so if you need your homework back, thank you. Make sure you put your name on it. All right, double check, make sure it's got your name on it. Yep. If you turned in homework last time, I've got it up here. The names on it. Yep. Okay.